The Earth contains a lot of breathtaking natural structures. From the highest mountains, hilly hills, down to the deepest part of vast oceans. Ever wonder how these structures are formed? In this video, we'll be touching three subjects. One is the convection current and how it works. Another one is the plate movement and its variations. And lastly would be the continental drift theory.
Lots of mechanisms that cause the plates to move are occurring beneath our planet's crust. And one of these mechanisms was accepted by most geologists as the most likely mechanisms for plate tectonics. And that is the convection current.
Convection current is defined as the circulation of fluid due to contrast in its density. It is a cycle where hot molten magma goes up and gets replaced by colder molten magma. As the cooler magma goes down, its temperature increases. The magma then goes up, creating a cycle. The continuous rising and sinking of materials creates a force, causing the plates to move apart, towards, or just slide to another plate. This is where plate movement steps in. But before that, let's talk about plate tectonic first. Plate tectonics is a theory that explains the structure of the Earth's crust and other related phenomena that was caused by slow lithospheric plate movement over underlying mantle. There are three plate movements that occur in three different boundaries: divergent, convergent, and transform boundaries. When two plates come together, it is known as a convergent boundary. The impact may form mountain ranges if the collision is direct, and a deep seafloor trench if one of the plates bend down. If one of the colliding plates is topped with oceanic crust, it is forced down into the mantle where it begins to melt. Magma rises into and through the other plate, solidifying into new crust. Magma formed from melting plates solidifies into a granite rock that makes up the continents. Thus, at convergent boundaries, continental crust is created and oceanic crust is destroyed. A divergent boundary occurs when two tectonic plates move away from each other. Lava then spews out between two tectonic plates. Molten magma then rises above and solidifies into a solid rock that forms a new crust. Thus, oceanic crust made of basalt is created. Two plates sliding past each other forms a transform plate boundary. Structures that cross a transform boundary are offset, split into pieces, and carried in opposite directions. Rocks that line the boundary are pulverized as the plates grind along, creating a linear fault valley or undersea canyon. As the plates alternately jam and jump against each other, earthquakes rattle through a wide boundary zone. In contrast to convergent and divergent boundaries, no magma is formed. Thus, crust is cracked and broken at transform margins, but is not created or destroyed. The two subjects that were discussed earlier are the main factors of a theory that was proposed by a German meteorologist and geophysicist Alfred Wegener, and that is the continental drift theory in 1915. he published The Origin of Continents and Oceans, which outlined his theory. According to Marder, 2018, Wegener postulated that about 200 million years ago, the supercontinent Wegener called the Pangaea began to break up. Over a million of years, the giant landmass separated, first into smaller supercontinents during the Jurassic period, called the Laurasia and Gondwanaland. And then, by the end of the Cretaceous period, into the 7 continents that we know today.
Still not convinced? Then, he had prepared 5 evidences.
The first evidence is the fit of continental shorelines. When looking at the map, he was intrigued by how Africa's and South America's shores were a perfect match to interlock. The continents looked like as if they were pieces of a giant jigsaw puzzle that could fit together to make one giant supercontinent.
The second evidence is the fossil distribution found on the continents that are separated by vast expanses of ocean. According to Marder 2018, similar fossils remain as if they were the Triassic island leptar Listosaurus and the fossil plant Gopsopteris. Exists in South America, Africa, India, Antarctica, and Australia, which were the continents comprising Gondwanaland. Another fossil that can be only found in Africa and South America are the Mesosaurus. It is an ancient freshwater reptile that is only a meter long that could have been not swum in the Atlantic Ocean, indicating that there were once a contiguous landmass that provided a habitat for it of freshwater lakes and rivers.
The third one is the glacier sedimentation found in the tropical striations in the tropical rainforest of Africa and South America. His theory was that those regions were not always located in the tropic, but might have been down closer to the South Pole and slowly drifted away.
Rock and mountain correlation is the fourth evidence Wegener collected. He studied rocks and peaks from all over the world and was able to match sets of mountains from different continents. For example, the Apalachian Mountain from the United States and the Caledonian Mountain from Scotland make a perfect match when put together on a map. Also, the Karoo Strata in South Africa and the Santa Catarina rocks in Brazil match perfectly. These pairs of mountains were made from the same kind of rock and same age sediments.
The theory has a paleoclimatic evidence supported, which is the last evidence of his theory. The theory said that the Earth during the Pangaea age was once cold. It contained many glaciations around the world. When the landmass broke apart, these broken pieces of land moved to 4 places, causing the existence of various climates that are still present until today. Some continents in the tropical zones experience wet and dry seasons. Continents in temperate zones experience the 4 seasons, which are spring, summer, autumn, and winter. Continents in polar regions experience extreme cold climate.
Now that we have tackled all 3 subjects, we learned that these 3 greatly contribute to the formation of the Earth. Without this, we cannot see majestic land formations, beautiful islands, and more.
Keep in mind that the Earth is continuously changing with the presence of convection current and plate movements, as well as a continental drift. Perhaps the mountains that we see today might not be the same in the future. Maybe in the next centuries to come, some countries will drift apart from us, some countries will get closer to us. If that is the case, then we will not be having a hard time traveling to another country in the future.
But anyway, that is a wrap, y'all. Thanks for watching and see you soon.